Hello, and welcome to the Module 6.4 Solving Absolute Value Inequalities Notes. Our objective for today is that I can solve absolute value inequalities. Our first example, solving absolute value inequalities with a less than symbol. So, for a real number a, the inequality, the absolute value of x is less than a, means that the distance between x and 0 is less than a. If the absolute value of x is less than a, then we can break it into this compound inequality, and since it's less than, it's going to be an and inequality. So x can be less than a, and x has to be greater than or equal to the opposite of a. So if we take a look at letter a in this example, we're going to have this inequality. The absolute value of x is less than 4. So we have the absolute value isolated. Our first step is going to be to split it into two inequalities, just like when we were working with equations. So we have x is less than 4. That's our first inequality. And then our second inequality is going to be x is greater than negative 4. Now, Mr. Boland, why did you switch the direction of the arrow or the inequality symbol? The reason we did that is because we changed that to a negative 4, right? We changed the sign of it. So that's like multiplying by a negative. And so we need to flip our inequality symbol as well. And so when we go ahead and graph this, we're going to put a point at positive 4, and we are going to shade to the left. It is an open circle at positive 4, and we're going to shade to the left. Okay. And we're going to put an open circle at negative 4, and we are going to shade to the right. Okay. Now this overlapped section here, this is our solution. And what this was saying is x, the absolute value of x, the distance x is away from 0 is going to be less than or equal or less than 4. So we could be as far, here's 0, we could be 4 units to the right, or we could be 4 units to the left, or anywhere in between. The distance away from 0 is less than 4. So it's at that 4 mark, and it's going inwards. That's why it's an and inequality. All right, let's look at letter B. Letter B, we have the absolute value of x over 2 is going to be less than 4. So we split it into two inequalities. So we have x over 2 is less than 4, and we're going to have x over 2 is greater than negative 4. And we go ahead and solve them both. So we multiply both sides by 2. And we're going to get x is less than 8. If we multiply both sides by 2, we get x is greater than negative 8. So we plot our points. Negative 8. And we have our point at positive 8. It's a less than, so they are both going to be open dots. So x is greater than negative 8, so we're going to the right from negative 8. X is less than positive 8. And so the blue section is the overlap. That is our solution, negative 8 to positive 8. All right, so let's do letters C and E because they'll both be on the screen at the same time. So we're going to do letter C. We split it into two inequalities. X plus 3 is less than 4. And we're going to have x plus 3 is greater than negative 4. And now we're going to go ahead and solve both of these inequalities. We subtract 3 from both sides. X will be less than 1. We subtract 3 from both sides. X is greater than negative 7. So let's plot these points. X is greater than negative 7. So we have a point at negative 7. X is less than 1. We have a point at 1. They're both going to be open dots. And we are going to be shading in between the two. Okay. So do we have to show both of them going to infinity? No, we don't necessarily, because I know that my answer is going to be contained in between these two numbers. So our distance away from 3 is going to be less than 4. So if we look at this, 3 is our midpoint there. It's halfway in between -7 and 1. That's our break line. Sorry, -3 is halfway in between, and that's our reference point, right? So letter E, we have the absolute value of x is less than or equal to -5. Well, let's take a look at that. Do we split that apart? Whoa, 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 whoa. We have a negative sign. The absolute value in the past when we dealt with equations could never be equal to a negative number because it's the positive distance away from 0. But with an inequality, can it be equal to negative? Or can it be less than a negative or greater than a negative? What could that possibly look like? So in this case, let's think about this. The distance away from 0, can it be less than -5? Well, no matter what I put in for x, the absolute value of that is always going to be a positive, no matter what. So a positive number is never going to be less than -5. So this is no solution because there is no value we could ever substitute in for x that would ever make that inequality true. So there is no solution for letter E. All right, let's take a look at letters D and F since they're both on the screen. So letter D, we have 2n plus 1 is less than or equal to 9. And we're going to have 2n plus 1 is greater than or equal to -9. And now we just need to solve both of these. So we subtract 1 from both sides of the blue equation inequality, and we get 2n is less than or equal to 8. Divide both sides by 2, n is less than or equal to 4. The purple one, we subtract 1 from both sides. We have 2n is greater than or equal to -10. Divide by 2, n is greater than or equal to -5. So I have a point at -5. I have a point at +4. They are closed dots at both of those. And we are shading in between the two. All right. Letter F. We're going to do the exact same work. So we have 2x minus 4 is less than or equal to 8. 2x minus 4 is greater than or equal to -8. And we're going to go ahead and subtract or add 4 to both sides. 2x is less than or equal to 12. Divide by 2, and we get x is less than or equal to 6. So I have a point at 6. Okay, my second inequality, we're going to add 4 to both sides. 2x is greater than or equal to -4. And then we divide by 2. We get x is greater than or equal to -2. Closed dot at -2. Closed dot at 6. And we are going to shade in between the two. All right. So there are now 6 U-try problems. I would like you to do those 6 U-try problems on your own and then come back and check your work against mine. All right, letter G. We split it into 2 inequalities. M plus 5 is less than or equal to 9. Subtract 5 from both sides. M is less than or equal to 9. Sorry, M is less than or equal to 4. So we have an open dot at 4, and we're going to shade it to the left. Okay, now my second inequality. We have m plus 5 is greater than or equal to -9. subtract 5 from both sides. M is going to be greater than or equal to negative 14. So we have a point at negative 14, greater than or equal to, oh, these are going to be closed dots, not an open dot. So it's a closed dot at 14, negative 14, closed dot at 4. And now I want to shade, we're going to shade to the right, and the green section is overlapping. So that's again another visual that we have these two sections that are overlapping, and you can see where they overlap, the color changes. And we get a brief insight into our optics units that we're going to do in science. All right, letter I, we have got 6x plus 12 is less than or equal to 12. So I'm going to subtract 12 from both sides. 6x is less than or equal to 0, divide by 6. X is less than or equal to 0. So that's my first value that I'm going to place, 0. And my second value, we have 6x plus 12 is greater than or equal to negative 12. So now when we subtract 12 from both sides, we get 6x is greater than or equal to negative 24. And then we're going to divide by 6. X is going to be greater than or equal to negative 4. So I have a point at negative 4. And again, these are greater than or equal to, so we have a closed dot for both of them. And then when we go to graph them, we're less than 0, and we are greater than negative 4. And so where we went from yellow and magenta, and now we get red. I wonder why that is. All right, let's look down at letter K. K is the absolute value of x minus 1 is less than or equal to negative 5. There is no possible value in the world that will satisfy this inequality. So it is simply no solution, because there is nothing you can do that after you take something away from it and you take the absolute value of that number is always going to be positive. It will never be less than or equal to negative 5. All right, letter H is a quick one. H is less than or equal to 5. So we have, X is less than or equal to 5. So X is less than or equal to 5. X is greater than or equal to negative 5. Negative 5, 5, closed dots at both of them, and we shade in between. Letter J. We have 2c minus 5 is less than 9. Add 5 to both sides. 2c is less than 14. Divide by 2, divide by 2. C is less than 7. Open dot. 2c minus 5 is greater than negative 9. Add 5 to both sides. 2c is going to be greater than negative 4. We divide by 2. And c is going to be greater than negative 2. So we have negative 2, greater than, and we are going to shade in between the two. Okay. Letter I, the absolute value of 5x is less than 15. So we have 5x is less than 15. And we have 5x is greater than negative 15. We divide both sides of each equation by 5, and we get x is less than 3. Divide by 5, divide by 5. X is greater than negative 3. So I have an open dot at negative 3. I have an open dot at 3. And we are going to shade in between the two. All right, so we have some very colorful notes here. We're going to move on to the next page, where we have absolute value inequality word problems. Yay, everybody's favorite. Okay, so Jonas is a software developer who wants to determine the changes he made to his program, if the changes he made to his program are popular with users. He releases a survey to get some feedback and finds 72% of users like the changes. The margin of error is within 1.8%. Write and solve an inequality that represents the percentage of users who like the changes. So whenever you do any kind of a survey, you're going to have a margin of error, and this is how accurate your survey can be. It's going to be a margin of error of 1.8% is going to be plus or minus 1.8%. So it could be 1.8% higher, or it could be 1.8% lower. Now, we want to write and solve an inequality. We want to write and solve an inequality. That is our task. And we want to know the users that like the changes. So let's start by defining a variable. X is users that like. It. Okay, so we are comparing the number of users that like it by the 72 figure that's in our survey, the 72%. We're comparing it because we know that the actual amount of people that like it is going to be within 1.8% of this 72 value. So X minus 72. And our range is going to be less than or equal to 1.8%, right? Because everything we're looking at is in percents here, right? X is percent, 72 is percent, our margin of error is percent. So X minus 72 is going to be less than or equal to 1.8. So now we need to just kind of focus in and solve that inequality. So X minus 72 is less than or equal to 1.8. And then we're going to add 72 to it. And we get X is going to be less than or equal to 73.8%. Okay, and our lower limit, we have X minus 72 is going to be greater than or equal to 1.8, negative 1.8. So it's going to be higher than if we took 1.8 points away from our total. So we add 72 to both sides, and we get X is greater than or equal to 70.2%. So if this was real data, Jonas would be looking at somewhere between 70.2 and 73.8% of his users like the changes that he made to his program, right? So margin of error tells us the high and the low of what it could possibly be statistically based on the data that you're providing. All right, so we're going to use the margin of error that's provided in this graph to write an inequality that represents the percentage of people who believe that we are doing enough to fight climate change. All right, so doing enough is 19%. We're going to use the margin of error in the graph, which is plus or minus 3.4 percentage points. And we want to write an inequality to represent it. So we are comparing, what are we comparing against? X is, we're going to use X is right here. X equals doing enough. So the absolute value of X minus 19 is going to be less than or equal to 3.4. And now we split this into two. X minus 19 is less than or equal to 3.4. And we're going to have X minus 19 is greater than or equal to negative 3.4. And we have to just solve these. Add 19 to both sides. X is going to be less than or equal to 22.4%. Add 19 to both sides. X is going to be greater than or equal to 15.6%. So based on this data from USA Today in August 9th through 15th of whatever year it is. They're looking at 1,361 registered voters, and it is going to say that based on that data, between 15.6 and 22.4% of people believed that we are doing enough to combat climate change. All right, let's look at example 4. Example 4 is solve absolute value inequalities that are greater than. So we have a similar definition here. For a real number a, the inequality, the absolute value of x, is greater than a, means that the distance between x and 0 is greater than that value a. So if x, the absolute value of x is greater than a, then we can break it into a compound inequality that x is greater than a, or x is going to be less than the opposite of a. And this should be an or, not an and. All right, so our first inequality, we have x is greater than or equal to 2. So if we have x is greater than or equal to 2, and then we have our opposite, x is less than or equal to negative 2. So if we go ahead and graph these now, we have a negative 2 greater than or less than or equal to, so it's a closed dot, and we are shading to the left. X is greater than or equal to positive 2, so it's a closed dot yet again, and we're shading to the right. So your absolute value, your value has to be outside of these limits in order for you to be greater than that distance. So this is an or inequality, and we are pointing out. Okay. So let's look at letter C since it's already on the screen. We've got x minus 1 is greater than 1. And then we're going to write our flip of it, x minus 1 is less than negative 1. And now we're going to go ahead and add 1 to both sides. We're going to get x is greater than 2. And on our other inequality, we're adding 1 to both sides. X is going to be less than 0, because negative 1 plus 1 is 0. So I have an open dot at 0. I have a closed dot, an open dot at 2. If x is greater than 2, we're shading to the right. And if x is less than 0, we're shading to the left. Okay. Letter E is a straightforward one. We have x is greater than 1, and we're going to have x is less than negative 1. We take the opposite. So we have a point at negative 1, we have a point at 1, and we have open dots for both of them because it is just less than. And we're going to shade to the left because it's less than negative 1. And we're going to shade to the right because it's greater than positive 1. Okay. Now let's go over and do letters B, D, and F. So letter B, we're starting off with x plus 1 over 3 is going to be greater than 2. I might give myself a little more room. We're going to have x plus 1 over 3 is going to be less than negative 2. So we start by multiplying by 3 on both sides. X plus 1 is greater than 6. Subtract 1. X is greater than 5. Multiply both sides by 3. And we're going to get x plus 1 is less than negative 6. And we subtract 1 from both sides. X is less than negative 7. So we have a point at negative 7, and we're going to be shading to the left. And let's not forget that it is an open dot. And we have a point at 5 that's an open dot, and we're going to shade to the right. Letter D. We have 3x minus 6 over 12 is going to be greater than or equal to 1. So my first step, multiply by 12. And we get 3x minus 6 is greater than or equal to 12. Add 6. 3x is greater than or equal to 18. Divide by 3, x is greater than or equal to 6. Okay, we have our second one, 3x minus 6 over 12 is going to be less than or equal to negative 1. Multiply by 12, and you get 3x minus 6 is less than or equal to negative 12. Add 6 to both sides. 3x is less than or equal to negative 6. Divide by 3. X is less than or equal to negative 2. So we have a closed dot at negative 2. And we have a closed dot at positive 6. We're going to shade to the right from positive 6. And we're going to shade to the left from negative 2. Okay. And lastly, on this page, we have letter F, 2m minus 9. So I'm going to kind of give us a little dividing line so we know where the previous question was. 2m minus 9 is greater than 13. So we have 2m minus 9 is greater than 13. We add 9 to both sides. 2m is going to be greater than 22. Divide both sides by 2. M is greater than 11. Our secondary equation, 2m minus 9, is less than negative 13. Add 9 to both sides. 2m is less than negative 4. Divide by 2. M is less than negative 2. So I have a point at negative 2. It's less than, so it's an open dot. And we're going to shade to the left. I have a point at 11. That's an open dot. And we are going to shade to the right. All right, so you're going to go on to the next page. And on the next page, we have letters G through J. These are 6 you-try problems that I would like you to do on your own, and then you're going to compare them against my work. All right, letter G. We are going to start by splitting this into 2 separate inequalities. X plus 3 is going to be greater than or equal to 4. And x plus 3 is less than or equal to negative 4. So we start by subtracting 3 from both sides. X will be greater than or equal to 1. Subtract 3 from both sides. X is less than or equal to negative 7. So I'm going to have a point at negative 7, and it's a closed dot. I'm going to have a closed dot at 1. We are shading to the left from negative 7, and we are shading to the right from 1. Okay. Letter I. We're going to separate it. We have 4m minus 20 is greater than or equal to 12. And we're going to have 4m minus 20 is less than or equal to negative 12. So first step is going to be adding 20 to both sides. We get 4m is greater than or equal to 32. Divide by 4. M is greater than or equal to 8. Okay. And on the blue one, we're going to add 20 to both sides. We get 4m is less than or equal to 8. And then we divide by 4. M is less than or equal to 2. So we have a point at 2, closed dot. We have a closed dot at 8. And we are going to shade from the 8. M is greater than or equal to 8, so we go to the right. And M is less than or equal to 2, so we shade to the left. Okay. Letter K, we have x minus 8 is greater than 5. X minus 8 is greater than 5. And we're going to have x minus 8 is less than negative 5. So we start, add 8 to both sides. X is greater than 13. Add 8 to both sides. X is less than 3. So we have a point at 3. That's an open dot. We have a point at 13. That's an open dot. At 13, we have x is greater than 13, so we shade to the right. At 8, we have x is less than 3, so we shade to the left. All right, letters H and J. So letter H, we have x is greater than 6. X is less than negative 6. Negative 6, 6. If we are greater than 6, we're going to shade to the right. It would help if I put a point in there. It's an open dot at 6. It's an open dot at negative 6, where we have x is less than negative 6, so we shade to the left. Okay. Next up, we're going to have 2n plus 5 is greater than 9. And we're going to have 2n plus 5 is less than negative 9. Start by subtracting 5 from both sides. 2n is greater than 4. Divide by 2. N is greater than 2. Subtract 5 from both sides. 2n is less than negative 14. Divide by 2. N is less than negative 7. So we have a point at negative 7. It's an open dot. We have a point at 2. It's an open dot. So if we are greater than 2, we're shading to the right. If we're less than negative 7, we shade to the left. Letter I, we have the absolute value of 3x is greater than or equal to 18. So our first inequality is 3x is greater than or equal to 18. Our second inequality is 3x is less than or equal to negative 18. We go ahead and divide both sides by 3. X is greater than or equal to 6. Divide both sides by 3. X is less than or equal to negative 6. So we have a point at negative 6, closed dot. We have a point at positive 6, closed dot. X is greater than 6, so we're going to go to the right. X is less than negative 6, so we go to the left. All right, now example 5 is absolute value inequalities that are greater than, that are going to have overlapping case solutions. So let's look at what is going on here? So we have the absolute value of x minus 6 is going to be greater than or equal to negative 5. Well, this is going to be the one time that we are going to not just automatically say no solution when we have a negative sign involving an absolute value. Because what we're looking for is the distance from 0 going to be greater than negative 5? Are we going to be able to have a value that is higher than negative 5 in that inequality? And that's going to be true. We are going to be able to find some values that are going to be greater than negative 5. So we're going to set it up. X minus 6 is greater than or equal to negative 5. And x, we'll do swap colors, x minus 6 is going to be less than or equal to positive 5. Now we go about the same way. We solve the inequality, add 6 to both sides, and you get x is greater than or equal to 1. On the right, we add 6 to both sides. X is going to be less than or equal to 11. So these are ors, right? They're pointing in opposite directions. And let's go ahead and graph them and see what we get. So we have a point at 11. It is a closed dot. And we're saying that it is less than or equal to 11. So we're going to shade to the left. X is greater than or equal to 1. Here's a 1. It's a closed dot at 1. And we're going to be shading to the right. Well, what does this end up meaning? The distance away from 6 is going to be greater than or equal to negative 5. Is it just this overlap section? No. No. This is going to be all real numbers. I can substitute any value I want in for x, and then subtract 6 from it, and take the absolute value of it, and no matter what value I substitute into that inequality, it will always have an absolute value that is greater than or equal to negative 5, because all positive integers and decimals are going to be greater than a negative 5. So this is all real numbers. Letter B, I want you guys to go ahead and do that one on your own and then check your work against mine. We're going to take the same approach. 2n plus 8 is going to be greater than negative 2. And we're going to have 2n plus 8 is less than positive 2. And we solve them. Subtract 8 from both sides. 2n is greater than negative 10. Divide by 2. N is greater than negative 5. Subtract 8 from both sides. 2n is less than negative 6. Divide by 2. N is less than negative 3. So we have a point at negative 3. That's an open dot. We have a point at negative 5. That's an open dot. We're going to be shading to the right from negative 5 because we're greater than negative 5. We're going to be shading from the left to the left from negative 3. And we're going to see all real numbers are going to be encompassed in this solution set because any value I can put into that inequality is going to give me a true inequality. No matter what, the absolute value of something is going to be greater than a negative value. So yet again, we have all real numbers. All right, and that's our notes for today. Greater than absolute value inequalities are going to be shaded out with a gap in the middle, most likely. A less than absolute value inequality is going to be pointing towards each other. It's an and inequality. and it must be in between those two values. If you have any questions, please bring them to class tomorrow. Otherwise, I hope you have a great day.